We're about to dive into one of the most incredible and, just plain counterintuitive engineering marvels on the entire planet. It's this massive fortress built to tame some of the rawest power of nature in one of the world's most volatile spots.
So, first things first, let's just wrap our heads around this scale we're dealing with. The Rogan Dam in Tajikistan, it's going to stand 1,100 feet tall. To put that into perspective, that's taller than the Eiffel Tower. It is an absolute behemoth.
And yeah, that staggering height makes it the tallest dam in the world. Now, when you picture a structure that massive, holding back that much force, your mind probably jumps to one specific material, right? I mean, it's gotta be concrete. Hard, unyielding, solid as a rock concrete. That's just how you build something this monumental so it lasts for centuries. It's really the only thing that makes sense. Or is it? Not even close. The core of the world's tallest dam isn't concrete at all. It's made of compacted earth and, believe it or not, clay. And the reason why? Well, that's a total masterclass in brilliant engineering. Okay, so to really get this, we first have to unpack why our gut instinct about using concrete is actually completely wrong in this case. It all comes down to a battle between rigidity and a very, very harsh reality.
We're all kind of taught to think that strength means being immovable. We look at skyscrapers, we look at bridges, we think of reinforced concrete, a material literally designed to resist force without bending. And look, most of the time, that's exactly what you want.
But the Rogun Dam isn't being built just anywhere. It's being constructed in a place where being rigid and unyielding is basically the most dangerous quality your structure could possibly have. The environment itself becomes the enemy.
So here's the problem: the location. The dam is in the North Caucasus region, which is a hotbed for intense, frequent seismic activity. And under that kind of violent, shaking stress, concrete's biggest strength, its rigidity, becomes its fatal flaw. It doesn't bend, it just shatters. The dam would crack and fail, and it would be absolutely catastrophic.
So if trying to resist the force is the wrong move, what's the right one? Well, the engineers found this incredibly elegant solution by looking not for rigidity, but for flexibility. And this is where the genius of clay comes into play. See, the Rogun Dam is what's called an earth-filled dam. So instead of one solid structure, think of it more like a massive man-made mountain of compacted earth, sand, and rock. But its true secret weapon, that's hidden deep inside. Right at the very center of this man-made mountain, that's where you find the key. A massive core made of compacted clay. And yeah, it's impermeable, so it holds the water back. But its most important job actually has nothing to do with stopping leaks. And this right here is the big aha moment. That clay core acts as a giant shock absorber. Instead of trying to fight the insane energy of an earthquake, it's designed to absorb it, to actually move with it. So here's the play-by-play. When those seismic waves hit the dam, the outer layers of rock and earth start moving. But instead of the whole thing cracking, that enormous pliable clay core at the center just deforms and shifts. It literally soaks up all that kinetic energy and dissipates it safely. The entire structure can wobble and flex without breaking, which is exactly what keeps it standing.
This all leads to a really profound lesson in engineering philosophy. It's all about finding strength, not in fighting nature, but in working in harmony with it.
I mean, the difference in thinking is just night and day. A concrete dam is brittle, it fights the force, and eventually it can crack. This earth-filled dam is flexible, it absorbs the force, giving it incredibly high seismic resistance. It's the difference between trying to resist nature and learning how to adapt to it. And that's really the big takeaway from this whole project. When you're in an environment that's defined by these powerful, unpredictable forces, the most resilient strategy isn't to build an immovable object. It's to create something that can bend without breaking. It's about working with your environment, not just trying to steamroll it. So it kind of leaves you with a final question to chew on. This principle, choosing flexibility over rigidity, it solved this massive engineering challenge. So where else could we apply that? What other complex modern problems, maybe in technology, in society, heck, even in our own lives, could be solved if we design systems that adapt and absorb pressure instead of just trying to resist it head-on?